So here we're given this, this polynomial. It's x plus 3 times x minus 2 quantity squared times x minus 5 cubed. And a lot of things we want to do here. We want to find the degree of the polynomial. We want to find the y-intercept. We also want to determine which of the x-intercepts crosses the x-axis and which of the x-intercepts will flatten out. Okay. So I mean, we don't need to graph this, but let's graph it. It may help us out, right? We can find the degree of the polynomial and the y-intercept pretty straightforwardly, right? So first thing we should do is just count out how many factors there are, right? So we don't need to do this, but we notice that it's x minus 2 squared, right? And it's x minus 5 3 times, right? So what does that mean? How many different factors of x are there, right? There are 6 different factors, which makes this, right? Which makes this a 6-degree polynomial. Okay. All right, so we don't need to, we can find the y-intercept later, okay? But, okay, well, let's do it now. How are we going to find the y-intercept? To find the y-intercept, we just plug in 0, right? So we just plug in 0 here, plug in 0 here, and plug in 0 here. So we get 3 times negative 2 squared, which is just 4, right? And then what do we get in this case, right? We get negative 5 to the third power, which is negative 125, okay? So if we multiply all these together, we get negative 1500, negative 1500. So that's going to be the y-intercept. Now when we sketch this guy, right? Once again, we don't need to sketch it, but we'll do so here just to help us out with the graph, right? And what we notice is it's a even polynomial with no negatives. So the end behavior, right? The end behavior should look a little something like this, right? It's going to go up and to the left, go up and to the right. We know where the x-intercepts are, right? The x-intercepts are at negative 3, at 2, and at 5. And what is the graph going to be doing? Okay, so at negative 3, it's going to go through. We're going to turn around, and at 2, we're going to bounce back. Okay, and then what's going to happen at 5? And we're going to go through it, and the end behavior sort of works out, right? This is how our graph should look. Okay. So which of these x-intercepts crosses the x-axis? Okay, remember, there's 3 x-intercepts, right? Okay, so which ones cross the x-axis? So the ones that cross the x-axis are going to be what? Negative 3 and positive 5, right? That is where the graph crosses the x-axis at the x-intercepts, okay? Notice what happens here. It doesn't cross it, right? It just touches it and bounces back, okay? Which of the x-intercepts will flatten out? So the x-intercepts that flatten out can be determined by the multiplicities, right? Anytime you have a multiplicity greater than 1, the graph will always flatten out. Okay, now I know it doesn't look like it here, right? But you notice that x equals 2, okay? And it's going to flatten out just a little bit and bounce back, right? But what happens at x equals 5, right? It's a multiplicity of 3, okay? So it shouldn't really go straight through like it does in negative 3 here, right? So at positive 5, right, it should flatten out just a little bit, okay? So any factor that has a multiplicity of greater than 1 will always flatten out, okay? So we got the degree, we got the y-intercept, and once again, we don't need the graph here, but we use the graph to help us, right? It's going to cross the x-axis at negative 3 and 5, and the x-intercepts will flatten out at 2 and 5.